In this lesson, we shall focus on this question here, which is a mathematics question, a part of what you call Euclidean geometry. We're given a circle with center A. We have the radius, which is CA, which is r units long. We have xy, which is 3r divided by 2. And so what we do is we present a solution to this particular question. We present a solution to this particular question. And so as we present a solution, we actually then have first and foremost been given that xy is 3r divided by 2. And we take note of the fact that at this point then, because we have that AT is perpendicular to xy, it must therefore bisect xy. And immediately we are able to see that xt is actually equal to ty, like this. And so what we are then seeing here becomes the fact that this is the case. Why? Because we know very well that we have a perpendicular from center, to chord. Right, we have a perpendicular from center to chord, and it therefore bisects the chord. By dint of this, we make the observation that we can actually be in a position to find xt, which is equal to ty. So if xt equals ty, it then means that we have 3r over 2 all divided by 2, which means that we have 3r divided by 4. Immediately, we are able to realize that this here is actually 3r out of 4, and this here is also 3r out of 4 as well. And with that, then we're able to actually make significant progress, but we are able to now proceed and also extract more information. In other words, what we have is therefore that we have this one is 3r out of 4, and this is 3r out of 4, and we have a radius here this way, and the radius is r units long. Right, and so, and this triangle obviously is actually a right-angled triangle. And so because of this, we can decide to work in this particular triangle. And we have that r squared is equal to at squared plus 3r out of 4 squared. Right, the reason for this is what you call Pythagoras. Right, is what you call Pythagoras theorem, or what you call Pythag. And so with that, then we're able to solve and get r squared is 80 squared 9r squared divided by 16, and we make 80 squared the subject, which is exactly r squared minus 9r squared out of 16. And so we have 16 divided by 1, which is 16 r squared, 9r squared. And therefore 16 minus 9 is actually exactly 7r squared divided by 16. And now with this then, if 80 squared is actually equal to this, we are able to make further observations. So we can take the square root of 80 squared, for example, and also take the square root of 7r squared divided by 16. And the implication of these becomes the next thing we actually will write down. So if we have the square root of 80 squared equals the square root of 7r squared divided by 16. So we have the square root of 80 squared, which is the square root of 7r squared divided by 16. So this means that we have AT is equal to the square root of 7r divided by 4. So that at this point, we have the following here. So we have that this one is exactly R. We've seen it. This one we said is 3R out of 4, and this one is also 3R out of 4, of course. And we've found AT, which is the square root of 7 out of 4R. And so with these then, we're able to actually make a significant progress, but we're able to then say, henceforth, we can be able to get CT. So, right, what is CT? Is exactly R plus the square root of 7R out of 4. And therefore, if you add this up, you take the following. You divide by 4. 4 divided by 1 is 4, which is 4R, plus the square root of 7R out of 4. And this is 4 plus the square root of 7 out of 4R, and this is CT. It's exactly CT. It's exactly CT. Right, so CT, therefore, is 4 plus the square root of 7 all divided by 4. Right, which is 4 plus the square root of 7 all divided by 4. And therefore, this is the answer. It is exactly the answer to the question, and it's exactly what we're to prove here. And we must thank you for lending us your attention. Until next time, take care and goodbye to you.